Hey boys and girls, so today we're going over Unit 5, Lesson 3, which is solving systems of linear equations using substitution. That's going to be huge today. All right, before we get started, just make sure your name is at the top, and let's begin. Do now consider the linear equation y equals 2x plus 5. If x equals 5, solve for y. All right, so the first thing I want to do is just rewrite this equation. Y equals 2x plus 5. As I'm reading, it's telling me if x equals 5, solve for y. So since I know that x equals 5, that means wherever I see the variable x, I want to replace it with the number 5. Okay, I'm substituting 5 in for x. All right, again, I have that plus 5, and then I just work it out from there. So y equals, let me grab my calculator, and I want to just type that whole thing in at one time. 2 times 5 plus 5, enter, and I get 15. So I know that y equals 15. All right, again, whenever I'm plugging in a number for a variable, we always do that with parentheses, don't forget, and then again, y equals 15. So I know that when x equals 5, y equals 15, I am good to go. This is called substituting, okay? We do this all the time. What we look at today, okay, is gonna be a little bit different because we're gonna use the substitution method on linear equations when we have a system, okay, a system of linear equations. One of the two ways we can solve systems of linear equations, I'm gonna highlight that because that is the topic for today, solving systems of linear equations. We can do this by method of substitution, all right? This is one method we can use. Tomorrow, lesson 4 will be a different method. The goal of this method is to replace one of the equations with an equivalent expression. I'm gonna highlight that as well. So I want to replace one of the equations with an equivalent expression, all right? And then I'm gonna use that to solve for the missing variables. So as we look here, we have two equations that would be a system of linear equations. The first equation is y equals x plus 7. The next equation is y equals negative 2x plus 1. As we look at our steps, the first step says we want to solve one equation for one of the variables. So we need just one of those equations. Let's highlight that out or box it. Underline it. We need one of those equations to say x equals, or it needs to say y equals. Well, we look out because both of these equations already are y equal, okay? I don't need the x equals, but it's nice if I have it. All right, so both of these are y equals. I have my first step ready to go. Number 2, I want to substitute the expression for the solved variable. The solved variable would be the x equal or the y equal, all right, into the other equation. So if I know that y equals x plus 7, I'm going to take that x plus 7 and I'm going to plug it in to my second equation. I'm going to replace y with x plus 7 because, again, y equals x plus 7. It's very similar to the do now. As I look at the do now up top, we knew that x equals 5, so again, that means wherever I saw an x, I replaced it with the number 5. That's what we're going to do down below. Here we go. Instead of writing y equals negative 2x plus 1, again, wherever I see that variable y, I'm going to replace it with x plus 7. I'm taking the first expression and plugging it into the bottom. That's the goal for today. Now, I have x on both sides. X is a like term, and I can solve this through just like I would any other equation. All right? And if you look at the first step, x and y, those are not like terms. I can't solve the first equation. I also cannot solve the second equation algebraically, all right, using math. So that's why we have to use this substitution method. I'm going to plug this in to my second equation. Now I can solve. I figure out that x equals negative 2. But I can't forget I had to solve for x and y. So after I substitute in and I solve for one of the variables, right now I know that x equals -2, my last step here is to then substitute that variable in to get the other one, all right? So if I know that x equals -2, I'm gonna replace in the first equation, let me write that again, y equals x plus 7. Now that I know that x equals -2, wherever I see an x, I'm replacing it with the number -2. So instead of writing x plus 7, I wrote -2 plus 7. Again, when I add this together in the calculator, I get 5. So I know that x equals -2. I know that y equals 5. And I'm going to write my final solution as a coordinate point. Again, I know a coordinate point is x, comma, y. And I am good to go. All right, let's flip and go to the next page and try to solve some of these together. All right, here we go. As I look at A, all right, the directions say, solve each of the following systems of equations algebraically. I'm going to underline that since that is the question. All right, and it's telling me to use substitution. I have to use substitution because that's the only method I have taught you so far. Here we go, part A. Do I have a y equals, okay, on at least one of the equations? Yes. It just so happens I have it on both, but I only need it on one. So the first step is good. Second step, I want to take that top equation and I want to plug it in to my second equation. I'm taking the first and I'm plugging it in to the second. Here we go. My second equation is y equals -x minus 1. I'm not going to write y equals. I know what y equals. Y is -5x minus 17. So instead of writing y, I am now going to plug in that -5x minus 17. All right, I'm going to replace this with my variable y on the left-hand side. The right-hand side stays the same. It's -x minus 1, and now I'm good to go. Instead of having an x and a y in my equation, which I can't solve, now I just have x on both sides, which I can solve. Here I go. I'm going to drop my train track here, and then I just combine like terms. Well, I know that to move a -17 over, I would have to make it the +17. I want to use that inverse operation. So whatever I do to one side, I do to the other. This will cancel, all right? So on the left-hand side, I have -5x equals, on the right-hand side, I have -x plus 16. All right, -1 plus 17 is +16. Now that I have all of my numbers on the right-hand side, now I want to move all of my variables to the left-hand side. All right, so the inverse of a negative is a positive, right? I'm just doing the opposite here. I'm going to add x to both sides. That cancels. Now I'm going to bring down my 16. That's going to equal, well, -5x plus a +1x gets me a -4x. And then last but not least, if I continue dropping my train track here, the opposite of a number and a letter, right, mushed together, that's multiply. So the opposite of multiplying is dividing. So I'm going to divide both sides by -4. This cancels. So I know that x equals -4 when I plug that in. All right, now be careful. Some of you might think that you're done because we solved for x. If I look back, there's not just one variable that I don't know, there's actually two. So now that I know what x equals, I can plug in that number in the first equation wherever I see the variable x. So again, I'm going to rewrite that equation again. Y equals -x minus 1. Originally, I had plugged in for the variable y, all right? I replaced y with what it was. I solved through. Now I know what x equals. So I'm going to replace x with that number that I know. Y equals -x minus 1. I know that x is -4. Anytime you plug in, you always use parentheses. Okay, so here I go. I'm going to type into the calculator exactly what I have. Negative, parenthesis, -4, close it, -1. Enter, and I get +3. So now I know that y equals +3, and I am done. I solved for x, I solved for y, and if I want to take it one step further, I can write my final answer as a coordinate point, which is x, comma, y, which would be -4, 3. All right, let's look at B. Here we go. As I look at B, the first step is to make sure that I have a y equals or an x equals in one of these equations, and I do. It's in the first one. So here I go. I'm going to take what y equals, and I'm going to plug it in to my second equation. So anytime I see a y, I'm going to replace it with 6x minus 11. Here we go. I'm going to start off by rewriting my second equation. -2x minus 3y equals -7. Again, I'm plugging in y to my second equation. So wherever I see a y, I'm going to replace it with 6x minus 11. And then that's going to equal -7. And I'm good to go. So I plugged in for y. All right, here it is. I know that y is actually 6x minus 11. I'm just plugging it in, replacing it. I'm really substituting in. And now I solve like I would any other equation. I'm going to draw my train track here. All right. I have a -2x. Now, I have to get rid of these parentheses by multiplying or distributing that coefficient in front. I have a -3. So I'm going to multiply -3 to 6x. And I'm also going to multiply -3 to -11. Well, -3 times 6x is -18x. -3 times -11 is +33. And again, that whole thing is going to equal -7. I'm going to continue solving. All right, I'm going to combine some like terms now. Well, -2x and -18x are like terms. So when I put those together, I end up getting -20x. And again, here's the calculator for that. -2 minus 18 is -20. All right, so I get -20x plus 33 equals -7. And then we just take it away from here. So I'm going to move that +33 over by using the inverse operation. I'm going to subtract it away. All right, now all I have left is -20x equals -7 minus 33. Here we go. -7 minus 33. Boom, -40. All right, I'm going to just drop my train track a little bit more here. And then again, whenever I have a number and a letter mushed together that's multiply, the opposite of multiplying is dividing. So I'm going to divide both sides by -20. This cancels. So here we go. I have x equals +2. Again, -40 divided by -20 is +2. All right. So now that I know what x equals, I'm going to substitute in a 2 anytime I see an x in that top equation. All right, so here I go. I am going to rewrite my equation on the side here. It doesn't matter which equation I plug into. All right, I know in part A, I substituted -4 into the second equation. I could have also substituted it in to the first equation. All right, the second equation just looked a little bit less busy. That's why I picked it. So as I look at part B, that top equation, again, it just looks a little bit less busy than the second equation. It looks a little bit easier. So I'm going to rewrite that first equation, which is y equals 6x minus 11. And then again, wherever I see the variable x, I'm going to replace it with the number 2. So instead of doing 6 times x, I'm going to do 6 times 2. All right, minus 11. Anytime you substitute in, you always use parentheses. And here I go. I'm going to type it into my calculator. 6 parentheses 2 All right, minus 11, enter, and I get a positive 1. So I know that y equals positive 1, and I am done. Again, if I want to take it one step further, I can write my answer as a coordinate point, which is x, comma, y, and I'm done. All right, as we look down below at C and D, C has a y equal, so I'm good to go. That means in the second equation, wherever I see a y, I'm going to replace it with a negative x plus 3. And if I look at part D, I don't have y equal, but I do have x equal, and that's okay. So now I'm going to switch it. I'm going to actually take the bottom equation and plug it into the top. If I know what x equals, that means wherever I see an x, I'm replacing it with the y plus 1. I want you guys to try C and D on your own. So at this point, press pause, give those a try, and then check back for the answer. All right, you guys, here are the answers to C and D. So in part C, like we said, I'm going to plug in negative x plus 3 to the bottom equation. So again, anytime I see a y, I'm replacing it with that negative x plus 3. Anytime you plug in, you have to use parentheses. Be really careful. Here's all my work I solved through, x equals 2. And now that I know x equals 2, I plugged it back in to the first equation because that one looked pretty simple. So I wrote it out first, y equals negative x plus 3. And then again, wherever I saw the variable x, I replaced it with a 2 using parentheses. When you type this into the calculator, you get positive 1. So x is 2, y is 1. Same thing with D. I took the bottom equation, I plugged it into the top. Anytime I saw an x, I replaced it with y plus 1. Again, anytime I saw an x, I replaced it with y plus 1. I solved it all the way through and got y equals 3. All right, and then again, that second equation didn't look, pretty busy. It looked pretty simple. So I plugged in y equals 3 to that bottom equation. All right, 3 plus 1 is 4. That means x is 4. Again, x is 4, y is 3. I wrote it like a coordinate point. And then I know that E and F are on the next page. Again, you guys should really try those on your own first. But again, here are the answers to E and F. All right, I'm just using that same substitution strategy. I am substituting one expression in for another. All right, so wherever I see an x, I substituted in 3y, just like I'm showing here, solved it through. All right, I did the same thing on F. You guys need to do the closure on your own, and you also need to get the homework done, which is that last page, which is here. All right, it's just 2 questions. Make sure you guys are getting the homework done. All right, have a great day.